Hello class, in this video we are going to review everything that you learned in 6th and 7th grade about inequalities, and then we're going to practice it with, I guess, slightly trickier equations. So in the homework for the last couple weeks, you've been seeing problems where you've had to use the inequality symbols. Hopefully now you're feeling really refreshed that this one means less than, and this one means more than. And that if you put the line underneath, that changes it to a less than or equal to. And same thing like that, more than or equal to. All right, so in 6th grade, you learned how to graph inequalities. And you did that by taking something like x is greater than 4 and showing that that means that 4 doesn't work because it has to be bigger than 4. 5 works, 6 works, 7 works. 4 itself doesn't, and we show that with an open dot, and then we do an arrow going up. Hopefully that feels sort of familiar. Go ahead and draw number lines for the next few. All right, so for x is less than or equal to 0, hopefully you did a filled in dot at the 0 and then the arrow going down to the smaller numbers. All right, this one's written backwards, so you would read it 1.5 is greater than x. You could also rewrite that if you wanted to help you think about it, that x is less than 1.5. Notice that it's always pointing at the same value. It's always pointing at the x here for this one. But if I want it less than 1.5, then I'm going to find where 1.5 would be on my graph. I'll make it an open dot because it's not equal to, that number itself isn't allowed. And we go down. And finally, we have x is greater than or equal to -6. So we need to make sure that we remember that greater than means bigger numbers higher into positives. So we're going to do a closed dot because -6 itself is allowed. And we're going to go up. Hopefully this is ringing all sorts of remind bells, and this is not new material. All right, so this next piece is something that normally I spend quite a bit of time trying to force our brains to really think through in class. Unfortunately, that would make my video really, really long. So we're going to kind of do a little brief version of that. So if we picture the inequality 2x is greater than 10, I want you to try and think of what numbers could x be that this would work. We want 2 times something to be bigger than 10. Can x be 5? Well, 2 times 5 is exactly 10, so that does not work. But x could be 6, because that would give you 12. X could be 7. X could be 8. X could really be anything bigger than 5, right? So let's draw that on a number line real quick. So maybe 0, 5, 10. And we're going to put an open dot at the 5, and we're going to go up. Okay, notice that that's the same thing as if I just divided both sides by 2. That gives me x is greater than 5. Okay, now what about if I have -2x is greater than 10? What numbers will work there? I want you to pause. I want you to think through like I did on the one before. Just try out numbers until you figure out which values of x are going to work for this. Be careful. All right, so maybe you started out by trying 5 again. -2 times 5, well, that gives you -10. -10 is definitely not bigger than 10, so 5 doesn't work. What about 0? -2 times 0, that gives you 0. 0 is definitely not bigger than 10. No way. Notice but I am getting closer, right? 0 is closer than -10 was, so I'll keep going in that direction. So what about -2 times -5? Oh, that gives me exactly 10, but that's still not what I want because 10 isn't allowed, or because it has to be greater than 10. What about -2 times -4? Well, that's 8. That's still too small. I must be going the other direction. -2 times -6 gives me a positive 12. So in this case, -6 works. -5 almost works. -7, that would be 14. That works. So I'm actually looking at numbers that are smaller than -5. So if I had -5 here, 0 here, and -10 here, I'm looking at all the values that are smaller than -5. So I need x values less than -5. And so just like before, all I needed to do was divide both sides by -2, right? -2x is greater than 10. I'm dividing by -2 to give me that -5 that's right there. However, in this case, my inequality switched directions. And the best way I have for explaining that is that negative coefficient up here, because we had a negative that we were multiplying by, when we divided that and got it to the other side, it switches the direction because smaller negative numbers are sort of like bigger positive numbers, right? And so we have to flip everything, including the direction that the arrow faces. This is a confusing piece, but it actually is really, really important that you have some sort of a understanding of it. So I'd encourage you to pause for a little bit, maybe try some other examples, test it out on your own, see if you can come to an understanding of why it is that we had to switch that inequality. The long story short is that you must flip the direction of the inequality whenever you multiply or divide by a negative number as one of your solving steps. So not just because it has multiplication or division in the problem, but if as one of your solving steps, you have to multiply or divide by a negative number, that's the spot when you flip it. Let's do a few examples. All right, let's go ahead and solve this one together. So I am trying to solve for x, and I have two different groups of x's on one side, so I should probably start by combining those. So I'm going to distribute this negative, so I get 3x minus x minus 2 is less than or equal to 0. Notice I did not flip because this wasn't a solving step, it was just a simplifying step. You only have to flip when you're doing the same thing to both sides of an equation. Next, I'll combine my like terms. That leaves me with 2x minus 2 is greater than or equal to 0. I'm going to add 2 to both sides. That's not a multiply or a divide step, so I don't need to worry about any flipping. So 2x is greater than or equal to 2. And now I'm going to divide. Should I flip my inequality? No, because I was dividing by a positive number, not a negative one. Dividing by a positive does not need a flip. Now, your last step should always be to check. And this isn't a perfect check because of the way inequalities are. You can actually end up with a wrong answer that passes the check, but it'll catch if you flipped the inequality the wrong way. So according to my answer, any numbers greater than or equal to 1 should work. So that means 2 should work, 3 should work, 4 should work, 100 should work, right? So then I'm going to take one of those numbers and I'm going to plug it in. So 3 times 100, just pick any random number that should work, minus 100 plus 2 should be greater than or equal to 0. Well, 300 minus 102, I don't even need to do that to know that it's definitely bigger than 0. So it passed my sort of partial check. Now, once you have your answer, I'm usually going to also ask you to graph it, especially the problems from the book. I'm going to be expecting to see number lines for, I think, every single one of those. So if this is 0, and that's 1, and that's -1, I want figures greater than or equal to 1. So close dot at 1, arrow going up. Ta-da. Okay, I want you to pause again and go ahead and solve these two. Make sure to put them on a number line when you're done. Start by solving like normal. That simplifies to negative 3 is less than 3x. I did not flip any inequalities because I didn't multiply or divide by anything. All I did on the step before was add or subtract. Now I'm going to divide by 3. I still don't flip because I divided by a positive number. Even though I'm getting a negative result over here, I divided by a positive number. So I'm good to go. I throw it on a number line. And I've written this backwards, but negative 1 is less than x, means x is greater than negative 1, reading it backwards. So then open dot, greater than negative 1. And then check, it looks like 0 should work. All these numbers up here should work. So I'll plug 0 in. So 3 minus 0 is less than 6. That is true. All right, next let's start by adding 3 to both sides. And then now I'm dividing by negative 5. So that's that time that we know we're going to need to flip. So now we get x is less than negative 2. So on a number line, that would be an open dot at negative 2 going down. And then I check. So if it needs to be less than negative 2, then let's say negative 3 should work. So I'll plug that in. Negative 5 times negative 3 is a positive 15. Minus 3 is greater than 7. Yes, it is. It works. That was my check. All right, now sometimes we see something called a compound inequality, where you have inequalities on both sides. All right, so go ahead and start just by solving each of these equations separately and ignore the and for now, just get a solution for each of them. All right, did you get x is less than negative 1/3 and x is greater than negative 5? So now let's think about what that means. So if we have some number that must be both less than negative 1/3, I'll go ahead and just put this on a number line here. So it must be less than negative 1/3. We'll say that's right about there. And it must be greater than negative 5. So if it's both of those things, then it must be all the numbers in between here are your solutions. So you can write that as x is less than negative 1/3 and greater than negative 5 as one combined compound inequality. Now, if instead I had said or, oh, why is only part of that deleting? That's weird. There we go. So if I had said or, then that would mean that either one separately is good enough. So anything lower than here would work, or anything bigger than here would work. Now you can picture how if it had been an or, then we would have had to say that the solution was all numbers. So you have to be careful when you're dealing with compound inequalities to really think about the number sets involved and whether it's an and or an or. I've added a Khan Academy for compound inequalities under the extension options. If we were in class together, everyone would do it. As it is, if you have time, I'd encourage you to take a look at it. All right, for your practice problem today, you are going to solve -4 times the quantity x minus 6 is greater than or equal to 20. You are going to check your answer and you're going to graph it on a number line. Good luck.